Today we are going to discuss about fluid kinematics. So my name is Dr. G.V. Rao, professor in the Department of Civil Engineering, Vijnan Institute of Information Technology, Duvada, Visakhapatnam. Right. So first we are going to discuss about what is velocity and acceleration. You know, what is fluid kinematics. Fluid kinematics means the study of fluids deals with the motion of the fluid without considering the pressure forces. That study is known as fluid kinematics. Right? First, we are going to discuss about what is velocity, what is acceleration. What is velocity and what is acceleration. Right? Now, let V is the resultant velocity at any point in the fluid flow. Right. This is the fluid mass. That is the resultant velocity is let V is the resultant velocity in the fluid flow, and U, small v, and small w is the velocity components in the fluid flow. That means this is the x direction, this is equal to y direction, this is equal to z direction. U is the x direction velocity, v is the y direction velocity, w is the z direction velocity. V, w are the components of velocity, right? Then the velocity components are function of coordinates and time, right? That are mathematically velocity components are given as already I have explained in the last class that the what is one dimensional flow, what is two dimensional flow, what is three dimensional flow. So in case of three dimensional flow, the flow parameters velocity, pressure, density, these are varies with respect to x direction, y direction and z direction. Therefore, the velocity is the function of x, y, z and t. Velocity is the function of x direction, y direction and z direction and with respect to t. And v, velocity v is the also function of x, y, z and t. And also w, this is also velocity component w in z direction is also function of x, y, z and t. Right? These are the components, velocity components in x direction, y direction and z direction. Therefore, resultant velocity v equal to ui plus vj plus wk. And finally, the resultant velocity v is equal to square root of u square plus v square plus w square. This is the very important formula where we are going to solve the problems. Resultant velocity is equal to u square plus v square plus w square, square root of, or resultant velocity is equal to square root of velocity component in x direction square plus velocity component in y direction square plus velocity component in z direction square. This formula is very important. Please remember. Right. Now we acceleration. Ax, ay, az are the total accelerations in x, y, z directions. Same way like earlier, this is x direction, this is y direction, this is z direction. Ax is the acceleration in x direction, ay is the acceleration in y direction, and az is the acceleration in z direction respectively. Right? Now, based on the chain rule of differentiation, acceleration in x direction equal to, acceleration is equal to velocity by time, here du by dt. Acceleration in x direction, ax is equal to, based on the chain rule of differentiation, generally acceleration is equal to velocity by time, that is equal to du by dt, that is in the x direction. This can be written as, based on the chain rule of differentiation, du by dt plus du by dt plus du by dt plus du by dt. Right here, please all of you see here. Now this is equal to dx dx, there is no change. dy dy, there is no change. dz dz, there is no change. Right from the chain rule of differentiation, acceleration ax is equal to du by dx dx by dt plus du by dy dy by dt plus du by dz dz by dt plus du by dt. This is the formula for the acceleration ax. But we know values that are du by dx is equal to u. That means du by dx, that is the velocity in the x direction. Du by dy is equal to v, that is velocity in the y direction. Du by dz by, right, this is the equation. We know the du by dx is equal to dx by dt, that means distance by time is equal to velocity is equal to u, and dy by dt with respect to time, this is equal to v, and dz by dt, distance by time in the z direction, is equal to w. Now in place of x by dt, dy by dt, dx by dt, dy by dt, dz by dt, we are going to substitute the values u, v, w. Now in place of dx by dy, dx by dt, we are going to take the velocity in the x direction. dy by dt, we are going to take the velocity in y direction. dz by dt, we are going to take the velocity in z direction plus du by dt. Now we have the acceleration in x direction is equal to u into du by dt, v into du by dt, w into du by dt, and du by dt. This is the formula. This is the formula for the determination of acceleration in x direction. Right? This is coming from this value, u into du by dx, v into du by dy, w into du by dz plus du by dt. This is the formula for the determination of acceleration in total acceleration in x direction. Total acceleration in x direction. Now we know one statement, that the steady flow, already I have explained to you, steady flow, unsteady flow, uniform flow, non-uniform flow, laminar flow, turbulent flow. Right now steady flow states that the flow characteristics, velocity, pressure, density. Here we are going to take the velocity. The velocity do not change with respect to time. That means dv by du by dt is equal to 0. Velocity do not change with respect to time, right, in case of steady flow, or dv by dt is equal to 0, and also dw by dt is also 0. These are the based on the steady flow statement, steady flow definition. du by dt is equal to 0 in case of steady flow, dv by dt is equal to 0, and dw by dt is equal to 0. Now here the flow is in the x direction. Therefore if the flow is steady, capital dv by dt is equal to 0, automatically du by dt is equal to 0. That means if the flow is steady, resultant dv by dt is equal to 0, automatically based on the steady flow, dou u by dou t is equal to 0, dou v by dou t is equal to 0, dou w by dou t is equal to 0, because of the resultant velocity is 0 in case of steady flow. So in place of du by dt, we are going to take 0. Right? This is the standard equation. In this case we are going to take 0 because the flow is steady. Right? We are going to take 0. Finally we have the steady flow. The acceleration in x direction equal to u into du by dx plus v into du by dy plus w into du by dz. Right? This is the formula for the determination of the acceleration in x direction in case of steady flow. Right? This is only in the x direction. Right, now we are going to discuss about the acceleration in y direction. Acceleration in y direction. Here also ay is equal to acceleration in y direction is equal to ay is equal to dv by dt. That means velocity by time. Velocity by time. Apply that chain rule of differentiation. Same way, dv by dt plus dv by dt plus dv by dt plus dv by dt. This is based on the chain rule. Here also dx dx dy 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 dy. This is the formula for the determination of acceleration. Here I have used only dx dx dy dy. This is for your remembrance. This is very easy technique. Dy dy, therefore dv by dt. This is the formula for the determination of acceleration in y direction. Acceleration in y direction. But we know the one statement dx by dt is equal to already I told you, distance by time in x direction is equal to u, and dy by dt is equal to 0, dy by dt is equal to v, and dw by dt is equal to w. That means velocity is equal to dx by dt is equal to u, dy by dt is equal to w, dw by dt is equal to dz. Sorry, this is dz by dt is equal to w. Now here we are going to take dx by dt. In place of dx by dt, we are going to take u, dy by dt, v, dz by dt taken w, and dv by dt. So from this equation, the acceleration in z direction is equal to dv by dt is equal to mu. That means u, velocity component in x direction, into dv by dt, right? And velocity component v in y direction into dv by dt, and w into dv by dz. Right, now ax is equal to u into dv by dx, u into dv by dx. Next v into dv by dy. Next w into dv by dy plus dv by dt. This is the formula for the determination of acceleration in y direction. If the flow is steady, that means the steady flow dv by dt is equal to 0. The resultant velocity dv by dt is equal to 0. In case of steady flow, automatically dv by dt is equal to 0, du by dt is equal to 0, or dw by dt is equal to 0. Now we are going to take dv by dt is equal to 0 because the flow is in y direction. In place of dv by dt, we are going to take 0, right? This is 0. Finally, we have the formula that is acceleration in y direction is equal to u into dv by dx plus v into dv by dy plus w into dv by dz. This is the formula for the determination of the acceleration in y direction if the flow is steady. Right? Now we are going to determine the z direction. This is also same way. What we have followed earlier cases. Az, that means acceleration in z direction is equal to, here also dw, velocity in z direction divided by dt, based on the chain rule of differentiation. Same, this dw by dt plus dw by dt plus dw by dt plus dw by dt. Right now here dx, dx, dy, dy, dz, dz. Right, this is the equation for the determination of acceleration in z direction, and also dx by dt is equal to u, we know, and dy by dt is equal to v, we know, dz by dt is equal to w, that already I have given. Now from in place of dx by dt u, dy by dt v, dz by dt w, then this formula is u into dw by dx, u into dw by dx, and v into dw by dy, v into dw by dy, and w into dw by dz, and dw by dx. This is the formula in case of acceleration in z direction. If the flow is steady, dou v by dou t is equal to 0, automatically dou w by dou t is equal to 0, because in case of steady flow, the flow parameters without the flow parameters or velocity of flow in the channel do not change with respect to time. Therefore, dou w by dou t is equal to 0. In place of this value, we are going to take 0. Automatically, this is 0. Finally, we have the formula for the determination of acceleration in z direction is equal to u into dou w by dou x plus v into dou w by dou y plus w into dou w by dou z. These are the formulas for the determination of the acceleration in x direction, y direction, and z direction. Right, this is the standard formula. Finally, we have to determine the what is the resultant acceleration or acceleration. Acceleration is equal to, this is formula, axi plus ayj plus azk, or the resultant acceleration is equal to square root of ax square plus ay square plus az square. Ax already we have determined earlier, ay is also we have determined there, az is also we have determined there. Therefore, resultant acceleration is equal to ax square plus ay square plus az square square root. This is the formula for the determination of the resultant velocity. Right? Right. Here, all these are the total accelerations. Now we have determined the acceleration in x direction, acceleration in y direction, acceleration in z direction. These are the total accelerations. Now we are going to determine only two heads. This total acceleration is classified into two ways. One is local acceleration and another one is the convective acceleration. Local acceleration means the rate of increase of velocity with respect to time. The rate of increase of velocity with respect to time, that is known as local acceleration. Okay, so the local acceleration ax, the total acceleration ax is equal to, what is the formula? U into du by dx plus v into du by dy plus w into du by dz plus du by dt. This is the formula I have determined in x direction acceleration, but the rate of increase of velocity with respect to t only, with respect to time only. Therefore, this entire time is cancelled in case of local acceleration. In case of local acceleration, ax is equal to du by dt. Right? Whereas in case of y direction, here also only the rate of increase of velocity depends or rate of increase of velocity with respect to time only. Therefore, this term is neglected. Therefore, in case of local acceleration, ay is equal to dv by dt. And in case of z direction also, the rate of increase of velocity only with respect to t. These are neglected here also. Therefore, a z is equal to dw by dt. In case of local acceleration, ax, that means acceleration in x direction is equal to du by dt, acceleration in y direction is equal to dv by dt, acceleration in z direction is equal to dw by dt, because local acceleration represents that the rate of increase of velocity with respect to time only. Therefore, these terms are neglected. Location terms are neglected. These are the formulas for the determination of the local acceleration. right? These are the formulas, right? Now another one is the convective acceleration. Convective acceleration means convective acceleration. In case of convective acceleration, the rate of increase of acceleration due to change of position of fluid particle. Change of position of fluid particle, very very important term. The rate of increase of acceleration with respect to change of position of fluid particle. Therefore this is not depends on time. So this is the acceleration in x direction, acceleration in y direction, acceleration in z direction. These three already I have determined. So this is not depends on time. Therefore this term is neglected. In case of x direction acceleration, in case of y direction, this term is neglected. In case of z direction, this term is also neglected. Therefore convective acceleration in x direction, ax is equal to du u into du by dx plus v into du by dy plus w into du by dz, because the rate of increase of velocity is due to change of position of fluid particle. That means only depends on directions, x distance, y distance, these positions. The increase of velocity depends on the position, so not depends on the with respect to time. Therefore we have used that last terms are neglected. This is the acceleration in x direction in case of convective acceleration. In case of y direction, that is equal to u into dv by dx plus v into dv by dy plus w into dv by dz. Here also we have neglected dv by dt. Right? This is the acceleration in y direction. This is the acceleration in z direction. That is convective acceleration in z direction equal to az is equal to u dw by dx plus v dw by dy plus w dw by dz, and this term is also neglected here. That convective acceleration is not depends, only varies with respect to change of position of fluid particles. These are the accelerations ax, ay, az, convective accelerations in x, y, z direction. We are going to solve one problem related to local acceleration and convective acceleration and also velocity. Right. What is the problem here? The velocity vector in a fluid flow gives, this is the velocity vector given, that is equal to 4x cube I minus 10x square yj plus 2tk. Find the velocity and acceleration. Find the velocity and acceleration of fluid particle at points 2, 1, 3 at a time is equal to 1. First we are going to determine the velocity. We know velocity formula. Velocity is equal to square root of u square plus v square plus z square. Right? From this given equation, first we are going to determine the what is u, that is the velocity component in x direction, what is v, velocity component in y direction, what is z, velocity component in z direction. Right? Right here, this is u, this is v, and this is w. Right? First we are going to note down u is equal to 4x cube and v is equal to minus 10x square y, and w is equal to 2t. Right? This is the u, v, w. Now we are going to determine the u at a point 2, 3, 4. That indicates that 2, 1, 3 means at x is equal to 2, y is equal to 1, z is equal to 3. Right? So u is equal to, x is equal to 2. That means 4 into 2 cube is equal to, right, 32 units. That is equal, u is equal to 32 units. V is equal to minus 10 into x square. X is 2 square into y is 1. That is equal to 4 into 10, 40 into 1 minus 40 units. This is the v. this is the x, and w is equal to w is equal to what? 2 into t. This is equal to 2 into time is taken as 1, that is equal to 2 units. Right. Finally, we are going to determine the velocity. Velocity vector is equal to, what is the formula? U square. What is the U square? U is equal to square root of, this is equal to square root of U square 32 square plus V square minus 40 square plus Z square. Z is equal to 2 square. This is equal to 51.26 units. This is the velocity, right? Next one we are going to determine the acceleration. Right, what is the formula for the determination of the acceleration? Acceleration means, here two types of accelerations already I told you. One is local acceleration, another one is convective acceleration. But they have not mentioned determine the local acceleration or convective acceleration. Here total acceleration formula is this one, that is equal to ax in the x direction is equal to u into du by dx plus v into du by dy plus w into du by dz plus du by dt. For that we are going to determine the first what is u, what is v, what is w, then what is du by dx, what is du by dy, what is du by dz, and what is du by dt. That terms we are going to determine here. First, based on this given velocity profile, u is equal to 4x cube, okay, and v is equal to minus 10x square y, and w is equal to 2t. Okay, u is clear, v is clear, and w is also clear. Now we are going to determine what is du by dx, what is du by dy, what is du by dz, what is du by dt. Right. Now du by dx, this is the u is equal to 4x square, differentiation of this value, that is equal to 12x square. Then du by dy, this equation differentiate with respect to y, that is equal to 0. And then du by dz, this equation differentiate with respect to z, this is also 0. Then du by dt, that differences, this u is equal to 4x cube, differences with respect to t, this is also 0. Right, this is about 1. Right, all are we have determined here. Next the acceleration in y direction is equal to u dv by dx, v dv by dy, w dv by dz plus dv by dt. Right, u, v, w already we have determined here. Then what is dv by dx, what is dv by dy, what is dv by dz, what is dv by dt. Right, dv by dx, that means that v differentiate with respect to x, therefore minus 20xy. dv by dx is equal to minus 20xy, and dv by dy, that means this differentiate with respect to y, that is equal to minus 10x square. And next one, dv by dz, this is differentiate with respect to z is equal to 0. And last one, dv by dt, that means this equation is differentiate with respect to t, this is also 0. Right, we have determined all these values, this one, this, all these values. And last one, the acceleration in z direction, az is equal to u into dw by dx plus v into dw by dy plus w into dw by dz plus dw by dt. These values already known to us. We are going to determine these values, right? Then dw by dx, dw by dx is equal to, that means this is the w 2t, this equation differentiate with respect to x, that is equal to 0, and dw by dy, this equation differentiate with respect to y is equal to 0, and dw by dz, that means this equation differentiate with respect to z, that is also 0. Then last one equal to dw by dt, that means this equation differentiate with respect to t, we have 2, right? All values are known to us in this equation. All these are substituting in the place of u, v, w, and dx, du by dx, du by dy, du by dz, like that, dv by dx, dv by dy, dv by dz, and du by dt, dv by dt, dw by dt. Finally, we have the some values that are the ax and ay and az, that are ax is equal to ax is equal to 1536 units, and ay is equal to 320 units, and az is equal to 2 units, right? These are the values we have determined based on the given velocity profile, right? Finally, we are going to determine the acceleration. Acceleration is equal to, we know one formula, a is equal to axi plus ayj plus azk. This is the formula. Now resultant acceleration, a is equal to square root of ax square plus ay square plus az square, right? This is the formula for the determination of the resultant velocity, right? We are going to substitute the values. Square root of ax is equal to 1536 square plus 32 0 square plus 2 square. Finally, we have the resultant equal to 1568.9 units. This is the acceleration of the flowing fluid, right?